This is section 8.5. We are adding and subtracting rational expressions. Last one we were doing multiplying and dividing. The objective is that students will be able to add and subtract rational expressions with and without common denominators. And that's really the thing that you have to understand today is how to do it without common denominators. If you guys remember back from elementary school when you guys learned about fractions, multiplying and dividing was pretty easy. Multiplying, you just multiply straight across. But with adding and subtracting, you had to find a common denominator first. So that's really what we're going to be working toward today is finding how to find a common denominator and then adding them once you have that common denominator. So the first thing we're going to talk about is with monomials. Now a common denominator, to find that, we're going to use what they call the least common multiple. And really it's the same thing. If I ask you the common denominator, the only difference is we can ask those when they're not fractions like these two. So for instance, if I had 5 over 6 plus 3 over 4, if we were finding a common denominator to add those, we would probably use 12. Well, 12, we use that because it's the least common multiple of these two numbers. It's a number that these both are factors of, but it's the smallest number. So it's the smallest number. You could use 24, but we want to use the smallest one today. So to find the least common multiple with a monomial like this, you find the least common multiple of your number. So between 8 and 12, our least common multiple would be 24. Then we have to find for our variables, it's always the highest exponent. So this is actually pretty easy. Look at your x to the 5th. My x to the 5th has a higher exponent. So that's x to the 5th. And your last one, we have y to the 3rd and y squared. You just take your highest exponent. Now, I want to make sure you can do this once we get common denominator. So I added, this is a little extra here. This is the least common multiple. That's our answer. But I want to know, what do we multiply this by to get that least common multiple? What do we multiply by 8xy to the 3rd? Well, we multiply the 8 by 3. What do we multiply by x to get x to the 5th? Well, we already have one x, so to get 5 of them, I need 4 more. And then what about y to the 3rd? Well, this has y to the 3rd. This one has y to the 3rd, so we don't multiply by anything. So multiply that out. 8 times 3 is 24. X times x to the 4th is x to the 5th. And y to the 3rd times, there is no y's, so it just stays y to the 3rd. So that's what we were looking for. Now what about the 12? Well, 12 times 2 is 24. X to the 5th, we already have that, so we don't need any more x's. And we have y squared. We need one more to get y to the 3rd. So 12 times 2 is 24. X to the 5th doesn't multiply by anything. And y squared times y was y to the 3rd. So that one's also good. So the next one, we have the least common multiple between 6a to the 5th and 12a to the 3rd b. Well, again, start with your numbers. Between 6 and 12, your least common multiple is 12. A lot of people put 24 for this one as well, and that would work, but we want the least common multiple. So 12 times 1 is 12, and 6 times 2 is 12. So that 12 is what we're going to use. Then look at your exponents. We use the biggest one, so that's a to the 5th. And b, well, this one doesn't have a b, which means this one must be the highest. So it's got to have that b. So that is our least common multiple for this one. Then we have 6a to the 5th. So what do we multiply? Again, this is a little extra. What do we multiply to get our least common multiple? We'll multiply by 2. Then we didn't multiply the a by anything, but we didn't have a b, so I have to multiply it by a b. So 6 times 2 is 12. A to the 5th doesn't multiply by anything, and then we don't have a b to multiply by anything, so we just end up with our least common multiple. Same thing with 12a to the 3rd b. 12 gets multiplied by 1, and then a to the 3rd gets multiplied by a squared. So we have 3 a's, I need 5, so I need 2 more, and then the b doesn't change, so this is all we have to multiply by. 12 times 1 is 12. A to the 3rd times a squared is a to the 5th. And then b times nothing is b. That is your least common multiples. So this one, again, just like the other lesson, I want you guys to do this one on your own. So pause the video, do this one on your own, and then hit play. Make sure, check your work, make sure you did everything correct. So start with your numbers. We have 6 and 10. So our least common multiple between 6 and 10. If you can't figure it out, you might want to list some. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7. You can keep doing that. Then you could even list your ones for 10, 10, 20, 30, 40. But hopefully, if you make a list, you only need one before you find 30 is that number that they both multiply to get. That's the smallest one. Again, 60 would work, but we want the least common multiple, the smallest one. Then our exponents, we have x squared. I have y to the third. This one doesn't have any y's, but have to take the highest exponent. And then this one doesn't have any z's, but we still need one for our least common multiple. So to get 30x squared y to the third z, 6 gets multiplied by 5. We already have our x squared, that's good. I need a y to the third, and we already have our z. So again, if you multiply that out, 6 times 5 is 30. X squared, sorry, make that a little cleaner. X squared, y to the third, then z. For our next one, 10 times 3 is 30. We have x, so we need another x to get x squared. We already have y to the third, and we don't have a z, so I have to add that z. So 10 times 3 is 30. X times x is x squared. Y to the third doesn't get multiplied by anything, and z doesn't get multiplied by anything. So those are both good. That least common multiple, 30x squared y to the third z. So now we're going to go on to the least common multiple for polynomials. So mostly binomials and trinomials for this. The key with this one is you're going to factor them, and then you want both of them to match. So you want the exact same thing. So we'll see what I'm talking about in a second. So let's factor both of these. Well, this one doesn't need factored. That's just x plus 2. This one, though, we do need a factor. So I need 1 times negative 12 goes on top. Negative 4 goes on bottom. You guys should be really good at this by now, since the last lesson we did this a bunch of times. Two numbers that multiply to be negative 12 that add up to be 4. Negative 4 are 2 and 6, and the 6 is negative. Said the right thing, or said the wrong thing, and put up the right thing. So we can take the shortcut since we don't have a leading coefficient. So that's x plus 2 times x minus 6. So we factored both of them. So now we're good. That's that first step. So now we need to get those to match. So this is what I always do. I always say, so what does this side have that this side doesn't? Well, this side has an x plus 2, but this side also has an x plus 2. So there's nothing that this side has that this one doesn't. So what about the other way? What does this side have that this side doesn't? Well, this one has an x minus 6, and this one doesn't have that. So we would have to add an x minus 6. So that is your least common multiple. We have x plus 2, they both have that. And then x minus 6, now they both have that. This little trick where I say you have to add it to this side, we're going to end up multiplying those. That's what I want to get in your head. You don't really need it for the least common multiple, but it's going to help you find the greatest common, or the common denominator later to get all those to match. So x plus 2, we need to add that x minus 6. Now they both have everything, they both share everything, so whatever they both are is your answer. So same thing with this one, we have to factor this. 1 times 10, factors of 10 add up to be 7 or 2 and 5. So x plus 2 times x plus 5. X plus 5 squared is just x plus 5 times x plus 5. You're going to want to take the time to write it out like that. That'll help. And now we need those to match. So this side has an x plus 2, and this side doesn't. So I need to add an x plus 2. This side has an x plus 5, but so does this one. But this side has 2 of them. This one only has 1, so I need to add 1 to this one. So now they both are the exact same. That's what your least common multiple is. X plus 2 times x plus 5 times x plus 5. And then all you have to do is multiply those out. I'm just kidding. You don't have to multiply those out. You can leave it like that. If you want to be Mr. Fancy Pants, you can leave it as x plus 5 squared, since there's 2 of them. I don't care. I would personally do this one because I'm pretty lazy. I would just leave it like that. So do this one on your own. Again, hit pause, do this one. If you get stuck, hit play, and then try to figure out where you're stuck and figure that step out, and then hit pause and finish it, or finish this whole thing and then hit play to check your work. So 1 times 12 is 12, that goes on top. Factors of 12 that add up to be 7 are 3 and 4. Again, if you guys aren't good at factoring, you better be taking notes and you better be doing this on your own because we're going to be factoring a whole lot. You guys have already seen it in the last lesson. This lesson, more factoring. Factors of -2 that add up to be factors of -15 that add up to be -2. Said that the other way around. So we have 3 and 5, and the 5 has to be negative. So x plus 3 times x minus 5. And again, the whole name of the game now, we need these to match. So this one has an x plus 3, but so does this one. So we're good there. But this one has an x plus 4, this one doesn't. So I need an x plus 4 over here. Now look at this one, we have an x plus 3, we have an x plus 4, that's good. And we need an x minus 5. So now they both match. They both have those 3 binomials. So that is your answer. X plus 3, x plus 4, x minus 5. Doesn't matter which order you put those 3 in. So now we're going to get to the adding part. Now, the biggest thing I've told you about the whole lesson is that we need common denominators. Now for this one, number 7, we already have common denominators, so this one should go pretty smoothly. Since we already have common denominators, that's going to be the denominator in our answer. Again, it's the same thing as if we had 1/2 plus 5/2. We have a common denominator, so that stays 2. Then we would add the numerators. We can only add the numerators if we have a common denominator. So we have that common denominator of x plus 2. That's good. That's what we want. Now we add our numerator. We have x squared doesn't add to anything. We have 6x and 2x. Those are like terms, so that's 8x. And we have minus 5. Now, once you get to this part, you could factor that numerator and see if you can get anything to reduce down. However, I'm going to tell you guys that you don't have to do that. Don't worry about it. With adding and subtracting, I'm not going to worry about factoring this last step and canceling things down. Technically, maybe I should do that. Maybe other teachers are going to be doing that. But I'm not going to worry about that for adding and subtracting. Multiplying and dividing, yes, we can worry about that. But for adding and subtracting, go ahead, leave your numerator there. The other thing, don't forget that if they ask you to, they don't do it a lot on this, but if they ask you for the excluded values or the restrictions on the variable, it's just whatever makes these denominators 0. So for this one, the excluded value would be -2. Now you don't have to do that on this one. They don't ask me that anywhere, but just make sure you remember whatever makes that denominator 0, it's still the same rules with adding and subtracting. So now we have this one. Now this one, the denominator are both monomials. So this one is going to be similar to what we did in numbers 1, 2, and 3 with this lesson. So we need a common denominator, so we need those to be the same. So just looking at the denominators, what is the least common multiple between 4 and 6? Well, that's going to end up being 12. We talked about that earlier. Then I have x to the 5th and x squared. You're going to take your highest exponent. So x to the 5th. Now this is what we were talking about earlier. This is why I did this at the very beginning. What do I multiply by 4x to the 5th to get that 12x to the 5th? Well, I need to multiply the 4 by 12, and then we already have the x to the 5th. Well, if I multiply the bottom by 3, I have to multiply the top by 3. Same thing over here. What did I multiply the 6x squared? What did I multiply that by to get the 12x to the 5th? Well, I multiplied the 6 by 2. I multiplied the x by x to the 3rd. Now we add your exponents, you have 5. So multiply the top and the bottom by that. So this is probably overkill, but I'm going to rewrite this just to make sure. 3 times x plus 4. And the main reason I rewrite this is because I don't like the order that these two are in, so I'm going to switch those. I always put my smaller one in front, my monomial I always put in front. And now you just multiply these out. 3 times x is 3x. 3 times 4 is 12 over 12x to the 5th plus 2x to the 3rd times 3x is 6x to the 4th. You multiply your numbers. 2 times 3 is 6. Add your exponents. And again, you could think of it this way. We have 3x's. I'm adding one more, so I have 4x's. 2x to the third times negative 2 is negative 4, x to the third, over our common denominator, 12x to the fifth. So now we have the same thing we just did. The good news is we know the common denominator. That has to be our denominator in our answer. Then you combine your like terms. So I have a 6x to the fourth. Then I have a minus 4x to the third. You don't need to put it in standard form with your highest exponent first, but I kind of like to do that. It's kind of a habit. So I have a positive 3x and a positive 12. Now, from this one, again, technically you could try to factor something out, but we haven't factored any that are quartics. We factored trinomials, quadratics, that was the word I was looking for, but we've never done with a power of 4. So we don't really know how unless there's a greatest common factor, but they don't have a greatest common factor. The 3 and the 4 don't share anything. And again, don't even worry about factoring for this adding and subtracting stuff. I'm not too worried about it. And excluded values, it doesn't tell us. Technically, it would be 0 for this one because that's what make the denominators both would be 0 if you plugged in 0. Now, moving on to the next step. And again, it's really the same exact thing we did. This one, they're not monomials. Now they're a binomial and a trinomial. So this is like number 4, 5, and 6. So first thing you do with finding the least common multiple is factor. Well, this one just stays x plus 2. This other one, write this over here, we have factors of 6 that add up to be 5, so that's 2 and 3. And actually, it might be not be a bad idea. I'm going to do this. Trying to give you more room on your paper, so yeah, let's just do it there. That's totally fine. So that's 2 and 3. So I end up with x plus 2 times x plus 3. Now, I know some people like to cross this out then because we're replacing that with this new denominator. You can if you want. You don't really have to. Just make sure you know that now we're done with that. We're working with our factored form. Now we need those to match. So this is what I was talking about earlier. They both have an x plus 2, so we're good. But this one has an x plus 3, so this one needs one. So we need an x plus 3. If you multiply the bottom, you have to multiply the top. So for our numerators, we have x times x plus 3 plus, over here we didn't multiply, over this side we didn't multiply by anything. So we have 4x minus 2. Now, technically, your common denominator is x plus 3 times x plus 2. Eventually, I might start leaving that blank because you guys already know, after this step where you found that common denominator, we already know that common denominator for our answer. So we need to multiply this out. So this x times x is x squared. X times 3 is 3x over, and then again, we already know what this is, so I'm not going to copy that down. Then we have 4x minus 2. We already know what that's going to be, and that's going to be that x plus 3 times x plus 2. So we already know those common denominators, and now we combine our like terms. So we have an x squared, 3 and 4 is 7, so plus 7x, and then minus 2. Technically, you can try to factor that, but I wouldn't even worry about it. And again, if they ask for excluded values, make sure, remember, it makes the denominator 0. So the excluded values would be x cannot equal negative 3 and negative 2. They don't ask us that, so I'm not going to worry about it. Let's look at number 10, then we'll do some on our own. Again, look at our denominators. We need a common denominator, so we need to do factoring. So we have negative 3, factors of negative 3 that multiply, or sorry, factors of negative 3 that add to negative 2. Got to be 1 and negative 3. Luckily, so far, we've been able to use a shortcut on all these. That kind of helps. Then, on this other one, factors of 12 that add up to be negative 7. This one's a tricky one. A lot of people say 3 and negative 4, but they're actually both negative. Again, check really quick. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. If you do that quick 3-second check, it'll help you get those positives and negatives correct. So we have x minus 3 times x minus 4. So, again, make those denominators match. They both have an x minus 3, so that's really nice. This one has an x minus 1, and this one doesn't, so I have to multiply by x plus 1. Both of them, the top and the bottom. Remember, if you do to the top, you have to do to the bottom, just like in normal fractions. Then this one has an x minus 4, and this one doesn't, so I have to multiply by x minus 4. Top and bottom. So now, again, now I know what my common denominator is going to be. It's going to be that whole thing, x minus 3 times x minus 4 times x plus 1. That's all going to be my common denominator. Technically, I should write it in here. But we already know what it is, so we're going to leave it. So our numerators, we have 10 times x minus 4. And we have x plus 1. I'm going to put that first just because it doesn't have the 5 in front, but it doesn't matter. It's all the same. So 10 times x is 10x. 10 times 4 is 40. X times 5x is 5x squared. X times 2 is 2x. 1 times 5x is 5x. 1 times 2 is 2. Now, the good news with this is that really you should combine these like terms, and that's probably what I would do to get 7x. But really, you could do that right in this step, because now we're just adding everything together. So we'd have a 5x squared to start. Actually, I want to put that down here. So I have 5x squared to start. Then I have a 10x, a 2x, and a 5x. So if you add all that together, 10 plus 2 is 12, plus 5 is 17, so that's 17x. And we have a negative 40 plus 2. Negative 40 plus 2 is negative 38. So that is our numerator. Our denominator then is, again, that same thing we had up here. I just erased it. I probably shouldn't have. X minus 3 times x minus 4 times x plus 1. And again, just go ahead and leave it like that. That is totally fine. That's going to be a hard one to factor, if it can even factor. And again, this was that same denominator. I shouldn't have erased it. I should have just left it here. So again, I'll let you guys do this to save some time where you leave these. I just put parentheses here kind of as a placeholder, because you already know from this very first step, you know what your common denominator is going to be. So instead of writing it out 6 times, I can write it out once or twice and you'll be fine. So try these couple on your own. One of them is monomials, one of them are binomials, so be careful with those. So pause it, do this on your own, and then again, hit play and watch how I do it to check your work. So we have 6 and 8. We need the least common multiple between those. So the 6 and the 8, again, you could technically use 48. It was just going to be a pain. So instead, I'm going to use 24. So with 24, now I'm going to have y to the 8th, because that's the higher exponent. So now again, we go back and say, how did we go from 6 to 24? Well, I multiplied by 4. How do we go from y to the 3rd to y to the 8th? Well, I multiplied by y to the 5th. Because there's 8 of them total, I have 3 of them, I need 5 more. So multiply the top and the bottom by 4y to the 5th. Then, how do we go from 8 to 24? Well, I multiplied that one by 3. And then y to the 8th, well, we already had y to the 8th, so I just need to multiply by 3. So 3 times 2y plus 3. Now, I know some of you guys are going to get eager and try to skip this step that I just wrote down, but I wouldn't. I think it's going to help a lot if you make sure you write that down. Now, multiply this out. 4y to the 5th times 4y, that's 16y to the 6th. I have 5. I added 1 more to that when I multiplied. So I have 6 of them. 4y to the 5th 4y to the 5th multiplied by negative 2 is negative 8y to the 5th. There are no exponents with that. Again, it's over that common denominator. 3 times 2 is 6y. 3 times 3 is 9 over that common denominator. And now we can add our like terms together. 16y to the 6th minus 8y to the 5th plus 6y plus 9. Again, you don't need to put it in standard form, but I like to do that. I think it helps stay organized. I have my highest exponent to my lowest exponent. And my denominator is 24y to the 8th. Same thing, do this one on your own once you're done, or pause it and do it on your own once you're done. Hit play and then watch how I do it. Check your work. So we are adding these, so we need to find we need a factor. Sorry, we need to find a common denominator, which means we need a factor. So the good news with this one is a difference in squares. So when I factor this one, you end up with, let me erase those, 2x plus 6 times 2x minus 6. Our other one, we have 2x minus 6 squared, so I have 2x minus 6 times 2x minus 6. So to get these the same, this one they both have a 2x minus 6, but this one has 2 of them. So I need to add one to this one because it only has 1. So to add it to the bottom, I have to add it to the top. Well, this one has a 2x plus 6, and this other side doesn't, so I need to add a 2x plus 6. So now that is our common denominator, this big long string of stuff. So we have actually, I'm going to put 3x first. Again, I think it's easier to put your monomials first, if you can. And then that's your denominator. Then we have x minus 7 times 2x plus 6 over your common denominator. And again, our common denominator, we know, I probably should have you been writing this down, but that's okay. I'll give you that shortcut. 2x minus 6, 2x minus 6 times 2x plus 6. If you wanted to put 2x minus 6 squared, that's fine. But we already know that that's going to be our denominator. So we're finding our numerator now. 3x times 2x is 6x squared. 3x times negative 6 is negative 18x. X times 2x is 2x squared. X times 6 is 6x. Negative 7 times 2 is negative 14x. And negative 7 times 6 is negative 42. And again, those are all numerators over that common denominator, the one that we already know, we already put it down. So again, if you want to combine the 6x and the negative 14, you can, but you could just wait till this step because we're going to combine all our like terms. 6x squared and 2x squared is 8x squared. Negative 18 plus 6 minus 14. Do it on your calculator if you need to. Like me, I can't do it in my head. That's negative 26x and minus 42. That doesn't combine with anything, it looks. So that then is your answer for this one. So now we're going to get into subtracting. And really, there's not much different in subtracting besides the very first step. And I'm going to show you, I'm going to tell you, I would do this very first step on all of them. So the very first step, we have a minus sign. I would change that to a plus. But when you do that, everything after that in the numerator, not the denominator, everything in the numerator, the sign is going to change to its opposite. So the first thing I do is I change this, 2x plus 3 over 3x. I change it to a plus, and then everything in the numerator, I have a minus 5x squared, a plus 4x, and a minus 10. Everything changed to its opposite. Every single one of those. Once you've done that, now it's just an adding problem. So we already have a common denominator. That makes this one a lot easier. And now we combine our like terms. So I have a negative 5x squared. 2x and 4x is 6x. And 3 minus 10 is negative 7. Again, technically, we could look at excluded values and be 0 for this one. Technically, we could try to factor, but we I'm not going to worry about that. So just leave that as your answer. That's fine. Same thing with monomials. This one's a little bit less writing because I would just change it to a plus this way. And then the only thing that changes is your 10. So I just change that to a negative. Again, don't change your denominator at all. So the common denominator for these ends up going to be, looks like 15x to the 7th. So to get 15x to the 7th, I had to multiply this one by 3x to the 3rd. This one I had to just multiply by 5. So the top and the bottom need to multiply by the same thing. And 5 times negative 10, doesn't matter which order. So 3x to the 3rd times x is 3x to the 4th. I had 3 of them, and I had one more then. 3x to the 3rd times 4 is 12x to the 3rd. That's over your same denominator. 5 times negative 10 is negative 50, over your same denominator. If you don't want to write that down, that's your call. But you do need it in your answer, 15x to the 7th. I've seen some people that when they get their final answer, they don't put that denominator, they just put the numerator. So for this one, they would just put 3x to the 4th plus 12x to the 3rd minus 50. That's it. That's all I put down. You have to put the denominator to get full credit for this. So maybe I shouldn't tell you you can skip over that, but I understand it's kind of a lot of repetitive writing, so I'm okay with that. Just don't forget your denominator. Same thing, don't make this harder than it actually is. Again, right away, I'm going to change that to a plus, and it's going to change everything in there to its opposite. So I'm going to have 3x minus 1 over 2x plus 5 plus, now I'm going to have negative 2x plus 5. Both of those change to their opposites. I'm going to have 4x plus 3. Now factor and get those to match. Now the thing with this one, we haven't had one like this, I don't think, but they're already factored. Well, what do we do then? Well, we still need to get them to match. So this one needs to have that 4x plus 3 with it. This one needs to have the 2x plus 5 with it. They are factored, you're absolutely right, but we still need to get those to match. So again, in our answer, our denominator is already going to be 4x plus 3 times 2x plus 5. So our numerators then for this, we have 4x plus 3 times 3x minus 1 plus negative 2x plus 5 times positive 2x plus 5. Again, I like to put these lines to make sure I remember there's a denominator in here. Sometimes I put parentheses. Then multiply this out. 4x times 3x is 12x squared. 4x times 1 is negative 4x. 3 times 3x is positive 9x. And 3 times negative 1 is negative 3. Again, if you want to combine that negative 4x and 9x, you can. I would just wait and do it when you all do it at the same time. Negative 2x times 2x is negative 4x squared. Negative 2x times 5 is negative 10x. 5 times 2x is positive 10x. And 5 times 5 is 25. Run out of room here. So combine your like terms. I have 12 minus 4 is 8x squared. This one I have a negative 4x plus 9x minus 10x plus 10x. Actually, the 10x's cancel if you want to do that, but you can put in your calculator. Negative 4 plus 9 minus 10 plus 10 is positive 5, so that's positive 5x. Then I have negative 3 plus 25 is positive 22. So sorry you ran out of room there a little bit, but I think you guys can see that enough. Then 16, same thing. We have a difference in squares. So this is x plus 5 and x minus 5. Whoops. Sorry, before I do anything, I should change this minus to a plus. Sorry, I got distracted. X squared minus 25 plus negative x minus 8. I would do that before I even factor. That was a mistake. I didn't mean to do that. And I know if somebody tries to factor first, they're going to forget that and they're going to miss this problem. So don't factor yet. Wait till you get that subtraction to be a plus. Now we have a difference in squares. If you factor this one out, factors of 10 that add up to be -7 are 2 and 5. And they're both negative, so they both multiply to be a positive. They both add up to be -7, so that's good. X minus 2, x minus 5. And we have to get those to match. So this one needs an x minus 2. This one needs an x plus 5. So our denominator, we know in our answer, is going to be x minus 2 times x minus 5 times x plus 5. So we already know that. So our numerator for this one, we have 6x times x minus 2 plus, I'm going to run out of room again, plus negative x minus 8 times x plus 5. So that's 6x squared minus 12x. Just distribute that. Plus, and then we have, sorry, I'm going to make that look more like an x. Then we have plus negative x times x is negative x squared. Negative x times 5 is negative 5x. Negative 8 times x is negative 8x. And negative 8 times 5 is negative 40. Again, those are both fractions over that common denominator that we already know. So combine your like terms. 6x squared minus x is 5x squared. I have negative 12x minus 5x minus 8. So negative 12 minus 5 minus 8 is negative 25. And minus 40 doesn't have anything to combine with. That is your answer for this one. Again, don't make that harder than it is. It's the same thing. We've been doing the same thing pretty much all day. 2 more to do on your own. So pause it, do it on your own quick, then hit play to check your work. I need to change this to a plus first. So this is going to be, this part doesn't change. 3x squared plus 9x plus negative 12 over x squared minus 2x minus 15. So factor the denominators. This one I can take out a 3x, so that leaves me with 3 divided by 3 is 1. I had 2 x's and I took 1 out, so I have 1 left. 9 divided by 3 is 3. I had an x and I took it out, so it's just x plus 3. And this one, factors of negative 15 that add up to be negative 2 are 5 and 3, and the 5 has to be negative, so x minus 5 times x plus 3. And we need to get those to match. So this one needs an x minus 5. This one has one. This left side doesn't, so we need to add that. This side needs just needs this 3x. So I just multiply it by 3x. So again, our denominator for our answer is going to be x minus 5 times x plus 3 times 3x. You don't really have to put that in front, but I kind of like to. I think it looks a little bit better with that smaller one in front. And our numerators, we have 10x times x minus 5 plus 3x times negative 12. 10x times x is 10x squared minus 50. X, that was close. And 3x times negative 12 is negative 36x. Again, we have that same denominator in here. So combine your like terms. I have 10x squared. Negative 50 minus 36 is negative 86x. Don't have to multiply your denominators. Don't find excluded values for this one. You're good to go. Again, we technically could factor an x and at least a 2 out of the numerator, but I'm not even going to worry about it. I would rather see if you can add and subtract first. So this is the other one to do on your own, so please pause it, do this one on your own, and then hit play to check your work. I need to change this to plus, so I have 5x over 2x plus 4 plus negative 6. Remember, it changes that numerator. 2x minus 10. So factor out the denominators. I have 2 times x plus 2. This one I have 2 times x minus 5. I need to get those to match. Well, the good news is they both have the 2's. This one needs an x plus 2. This one needs an x minus 5. So again, we already know our denominator is 2 times x minus 5 times x plus 2. And our numerators, we have x minus 5 times 5x and negative 6x times x plus 2. So we have, actually, I said before, I like to put my monomials first, so I'm going to go ahead and do that. 5x times x minus 5 makes it a little easier. 5x times x is 5x squared. 5x times negative 5 is negative 25x. Negative 6 times x is negative 6x squared. Negative 6 times 2 is negative 12x. So combine our like terms, we have negative x squared. Negative 25 minus 12 is negative 27. Negative 37, sorry, negative 37x. So that's your answer. And that's it for the lesson. If you have any questions, please don't hesitate to email me or ask your sub.